Hi friends, this is Gautam. In this video tutorial, I am going to discuss about introduction to routing. So we can see. So in this video session, we will take a look at the difference between switches and routers. Then I will explain you the basics of routing. So first of all, what is a router or what is a routing exactly? A switch switches and router routes. But what does this exactly mean? So for example, someone says switch will receive the frame and switch the frame. So router receive the IP packets and route the IP packets. So what does this exactly mean? So we can see. So we have seen the switches and you have learned that they switch based on the MAC address information. So the only concern for our switch is to know when an Ethernet frame enters one of its interface, where it should send this Ethernet frame by looking at the destination MAC address. So normally switch receive the frame. So once receive the frame, it will check the destination MAC address and check its own MAC address table. So based upon the MAC address table, switch will switch the frame. So switch make the decision based upon the data link layer. So OSA layer 2. So if you are not understand the OSA layer completely, means just go through that concept, then you can watch this concept. So you can able to understand. So routers have a similar task, but this time we are going to look at the IP packet, and as you might recall, IP is on the network layer. So OSA layer 3. So routers look at the destination IP address in an IP packet and send it out to the correct interface. So same like in router, what will happen? So router receives the IP packet, it will check the destination IP address and check its own routing table. Once it have that routing entry, based upon the routing entry, it will forward the packets. So that one only I mentioned in this point. So now I explained switches, I explained the routers. So now what is the big difference here? Switches receive the frame, it will check its own MAC address table. Based upon the MAC address table, the frame will be switching. So router receive the IP packet, check its destination IP address and check its routing table, and based upon the routing table, the packet will be forwarding. So what is the big difference here? First question. So second question, why don't we use MAC addresses everywhere and switch? So second question. So that means, so why don't we use MAC address and switches everywhere? So don't use routers, so kind of stuff. So third one, why do we need to look at the IP addresses and route? So third question. And finally, both MAC addresses and IP addresses are unique per network devices. So these are my questions. So if you know the answer for this question, just pause this video and below comment section you can reply your answer. So if you are not sure with that answer, just watch my video further. Okay, so now I explain you the main difference. So this is my example. Here I have two switches. So switch 19 left side I connected 7PC and switch 17 right side I connected 7PC. So just assume switch 19 have 100 computers and switch 17 also have 100 computers. So that one only I mentioned in the first point. So in diagram I am not able to show you that 100 PC connected. So just for example I connected 7 PC, but you assume switch left side and right side. So both switch have 100 computers each. So now 200 computers want to communicate with each switch, has to learn 200 MAC address. So both switch will learn 200 MAC addresses. So the need to know the MAC addresses of the computers on the left and right side. So left side switch have 100 computers and right side switch have 100 computers. So both switch to learn 200 MAC addresses in the MAC address table. So now you think about really a large network, for an example internet. So in an internet there are millions of devices are there. Would it be possible to have millions of entries in your MAC address table? So for each device in an internet, so it's a no way, it's not possible to learn all the MAC addresses. So the problem with the switching is that is not an scalable. So switch is not an scalable. So we don't have an any hierarchy. So just an 48-bit MAC addresses. So it's not possible. So let's look at the same example, but now we are using a routers. So same example, here I'm using a router instead of switch. So R1 router connecting towards the switch. So here I'm using 172.168.1.0/24 network, and R2 I'm using 172.16.2.0/24 network. So in R1 router, in this LAN segment I'm using 100 PCs, and R2 this LAN segment I'm using 100 PCs. So totally 200 computers. So here we can see, so what we have here is our 100 computers on the left are connected to R1. So the network is 172.16.1.0/24 network, and R2 as a 100 computers behind it, and the network we use over there is 172.16.2.0/24 network. Okay, now routers route based on IP information. So in our example, R1 only has to know that network 172.16.2.0/24 is behind R2. So same, R2 only needs to know that the network 172.16.1.0/24 network behind R1. So R1 wants to learn R2's LAN network, and R2 wants to learn R1's LAN network. So that one only I mentioned in this point. So instead of having MAC address table with 200 MAC addresses, we now only need a single entry on each router for each other's networks. So this is the main point. So switch uses the MAC address table to forward Ethernet frames, and routers use a routing table to learn where to forward the IP packets to. So this is the main difference. So if we are using switch everywhere means it's not an scalable, we are not able to learn that much of MAC address. So instead of using switches, we are using router, just we can learn only one entry. So using the router can learn one entry is more than enough to communicate with these 200 computers. So as soon as you take a brand new router out of the box, it will build a routing table, but the only information you will find there is directly connected interfaces. Let's start with this example. This is a new router. I am using two PC6 and PC13. So in PC6 to router R3, I am using 172.16.1.0/24 network, and PC13 connected to R3 router. So I am using 172.16.2.0/24 network. So this is my routing information. These are the direct connected informations. So above we have one router and two computers, and PC6 I will assign the IP as 172.16.1.1, and I configure the gateway as a 172.16.1.254. So PC13 I will assign the IP as 172.16.2.1, and I configure the gateway as a 172.16.2.254. So on our router we have configured IP address on Ethernet 1 interface 172.16.1.254, and Ethernet interface 2 I configured 172.16.2.254. Okay, since we are also configured a subnet mask, with the IP address, our router knows the network address and it will store in the routing table. So that's why here in the routing information it would store this network ID and subnet mask. So through which port we configured Ethernet 1, this one Ethernet 2. So it learn all the information in the R3 router. So whenever PC6 wants to send something to PC13, so what will happen? PC6 sends an IP packet with the destination IP address as 172.16.2.1. So PC6 check its own IP address and subnet mask, and it concludes 172.16.2.1 is an another subnet. So in last video session I will explain you the what is the default gateway. So if you are not watched that concept, please go through that concept and you can watch this video, you can able to understand. So it will conclude that 172.16.2.1 is an another subnet. So as a result, it will forward the IP packets to default gateway. So now router receive the IP packet, check the destination IP address and scans the routing table. So IP address, destination IP address is 172.16.2.1. It matches the 172.16.2.0/24 entry in the router. So now the router will forward that IP packets to Ethernet 2 interface. So PC13 will receive the IP packet and everything is good. So switches is not and scalable. It's not possible to use switch everywhere. So we can use a router. So router we have to learn only one entry. For our example, is easy to communicate all 200 PCs to each other. So for routing, there are two types of routings are there: static routing and dynamic routing. So in static routing, network administrator manually configure the path. So if you want to reach this network means you have to go via this path. So likewise the network administrator will configure manually. So that is a static routing. And dynamic routing have a different protocols. So all the protocols will work differently. So everyone, each and every protocol based upon that metric, cost and k value and attributes, it will find out the shortest path to reach the destination network. So in upcoming video session I will explain you the static routing as well as dynamic routing. So I hope you can understand this concept, introduction to routing and routers. So if you have any queries, please comment me in the below comment section. I will reply to your queries. And thank you friends, thank you for watching my video and subscribe my channel for further updates. Thank you.